Hello and welcome to another LeetCode problem. So today we're going to be doing swap nodes in pairs, and it's given a linked list. We need to swap every two adjacent nodes and return the head of the list. This is a good linked list problem to practice like basic pointers and flipping nodes and modifying nodes correctly. And I do apologize for this one if my mouse is a little weird and it takes me a little longer to draw stuff because I actually spilled some soda on my mouse pad, so currently I just have like a paper under my mouse. Okay, so let's look at this first example. So we have node 1, 2, 3, 4. So what we pretty much want to do is for every pair of nodes, we want to swap them, and then we want to return the output. So what we're actually going to do is let's actually take this, put it over here, and move it. Okay, so what we're actually going to do is we're going to create a dummy node, and it's really good for linked lists. So we're going to create this dummy node. It's going to point to the head, and then it's going to be our current node. And the nice thing about this dummy node is like when we have to swap a head and something else, now that we created this dummy node, it's okay, because otherwise it would be kind of annoying. And so it's going to be a pretty straightforward algorithm. So what we're going to do is we're going to have some kind of current pointer, and it's going to start the dummy node. So let's just say it's here. And then all we need to do is check, are there two nodes ahead of the current pointer, right? So we're going to go like 1, 2, and we're going to see, are there two nodes ahead? If there aren't, if there's only one node, then we can just return straight away because that means there's nothing else to swap. So if there are two nodes, what we're going to do is we're going to check. So we're going to have this current, and then we're going to check two nodes ahead. And then what we need is we actually need this node right here. So the node that is like after the two nodes. And so let's call this maybe like next or something. So let's call that this. And then all we're going to do, it's pretty straightforward. We just need these two nodes and we need to swap them. So how do we actually swap the nodes? Well, we can just have some labels for these two nodes, right? So we can have like a node like this, like first and second maybe or something. So this is going to be kind of our algorithm, and we're going to keep doing this until we don't have two nodes in front of our current. So if you think about what does a swap actually look like, well, actually it's pretty straightforward. So the current node needs to point to the second node, whatever that is, and then the second node needs to point to the first node, right? And then the first node needs to point to the next node. And so if we actually do that in this picture, so our current is the dummy node, so I'll just do that. So we're going to point to the second node, which is the 2. And then that's going to point to the 1, which is the first node. And then that's going to point to this 3, which points to the 4. So that's going to be the same. So we swap those two nodes, as you can see. And now we just do that again, and we just move up our current. So when we had a current node originally, what we need to actually do is we need to move it up two nodes again. So now our current is here. And then we have a first here and a second here. And so we check again, do we have two nodes in front of our current node? Well, yes, we do. So we need to do the same thing. So we need to do this like swap thing right here. And then we do have a next node, so except this next node points to none. So this would be like none or null or whatever it is in your language. And so let's see what that looks like again. So we need to take the current, have it point to the second. And so what's that going to look like? Let me actually draw this. So this is our current node. So we need it to point to the second, which is over here. So that's going to point to the 4. And that's going to point to the first node, which will be the 3. And then that's going to point to the next node, which is this none thing right here. So this will just point to none. And the rest of our list is still the same, right? So we had this dummy, point to 2, point to 1. And so this is our like full result right here. And then we move the current up again. So now the current moves up 2. And then we ask, do we have two nodes in front of the current? Well, no, we do not. We just have a none straight away. So then we just return. And then the nice thing about this dummy node is we can just return the next node of the dummy, which will be the head of our new list. So I would definitely recommend if you're doing node swaps to have a dummy node. And so that's pretty much it. So we just have this current node. We check if there's two nodes in front. We call them something. And then we also need the node that's after them. If it's none, if it's a node, whatever. And then we just have to like use this picture to get. And I would also encourage you for these linked list problems, when you do node swaps, I definitely encourage you to draw it out, or when you do like a dry run of your code, I would say like look at your code and then draw out like what all the nodes would be like, because you might like it's going to be very easy to spot bugs in your linked list problems if you just actually draw out, like you look at your code and you draw out the picture of like, okay, I did something, here's what my linked list is now, and so on. Okay, so let's actually code that up. So we're going to make a dummy node, and I believe, so the number of nodes on this list is 0 to 100. I think it'll still be fine if there are no nodes in the list. Yeah, it should still work. So let's make a dummy node. So list node. We're going to have it value 0, and then its next is going to be the head. And then cur equals dummy. And then we need to say while cur.next and cur.next.next. So this is like saying, is there one node in front and are there two nodes in front? Because if there's only one node in front, no nodes in front or anything, then we don't need to do anything. So here, we need a couple things, right? Remember from our picture. So we can call first equals cur.next, and second equals first.next. So that's going to be like in this picture here. Yeah, my mouse is being annoying. So like first will be over here, and then second will be the next pointer of this first, and then the next node is going to be the next pointer of this second. So we can just say that's going to be nxt maybe equals second.next. So this is the first node that we need to swap, the second node we need to swap, and this is the node that's after the two nodes. Okay, so now that we have those, remember, let's go back to our drawing. So what do we actually need to do? So we need to have cur point to second, second point to first, and then first point to next. So let's do that. So cur.next equals second, second.next equals first, first.next equals nxt. And then I believe that's it, right? So we just do these three swaps. So yeah, so the current points to first, first points to second, second points to nxt, like in this picture here. And then I think we are done. Now we also need to update our cur. So at the end, we're going to do cur equals nxt, I believe. Yeah, so remember we need to move our cur up twice. And so it's actually going to point to what the actually, sorry, it's not going to be the next. It's going to be this first, right? Yeah. Because in our example, like if we're here and we swap these two nodes, we're going to have, this is going to be second here. Yeah, so when we swap these two nodes, they used to be first and second, but now they're second, then first. So we actually need our cur to be this node right here. We need our cur to be the node before the nodes we're swapping. So we need to move it up two nodes exactly. You could also do something like this if you wanted to, if this is easier for you to understand. Like you just move it up next twice. Totally fine. In fact, I'll just leave it like this. So we just move it up two nodes. Now, when we don't have two nodes that we can go up, then we just return the dummy.next here, just like in our picture. Our dummy is going to point to the new head of the list. Let's try that. Okay. All right. And let's talk about the time and space complexity here. So yeah, like I would encourage you to try this problem out. And these linked list problems, when you first start doing linked list questions, it's very easy to make mistakes. And so, like I said, I would encourage you to like draw out this entire list to begin with and go line by line and see what you actually did. And then it's really easy to figure out what you did. And it's not super hard because this list is only 4 items. So it's definitely easy to just like go over this code and draw out the lists and then draw out the actual connections you make in your code. And you're going to find it's really easy to debug that way, where otherwise it's going to be like almost impossible to debug if you have some error. Like, how do you know what points to what? It's kind of difficult. So, okay, so space and time. So time, we are going to go through this whole list and we're going to be swapping nodes. That's big O of n, where n is the number of nodes. Pretty straightforward. And then space is going to be big O of 1 because we didn't actually make any new nodes. We just swapped pointers. So that's that. So if you like this problem, please like the channel or the video and subscribe to the channel. It helps grow the channel a lot. And I'll see you in the next video. Thanks for watching. Bye.